Guys, welcome to Java Core Programming course, Section 1, Lecture 1. Lecture 1 agenda. We will discuss Introduction to Java Programming Language, how to compile and run Java programs, and our first program, Hello World. Let's begin our lecture. Introduction to Java Programming Language. Java language is developed in 1995. It is an object-oriented programming, it is imperative programming language, and it is a procedural programming language. And when we will move to object-oriented programming lectures, I will discuss object-oriented aspects of the Java programming language. Java is platform independent. It has a slogan, write once and run anywhere. Actually, Java programs are compiled into a bytecode. The bytecode is then interpreted by the Java virtual machine and executed. So it is independent of the platform because every machine has a JVM installed, for example, Windows, Mac, or Linux. Core Java comes under Java SE, that is Standard Edition. There are various versions of Java. Java is started from Java 1, Java 1.2, and Java 1.3, and so on. The first major revolution came into Java programming language is Java 1.5. At that time, it introduced Java generics and other lot of new things. And then major revolution came into Java programming language from the version Java 1.8 when it introduced a lot of the functional programming concepts, streams, and a lot of new things. And now current Java version is 1.18. We will cover topics like object-oriented programming, inheritance, exception handling, polymorphism. We will start from basics like data types, variables, constants, operators, arithmetic operations, and gradually we move to branching, control statements, loops, and then object-oriented programming. You need JDK, Java Development Kit, to compile Java programs. How to install JDK and set Java home. You can watch another video in the configuration playlist. Java programs compile to a data class files and are bytecode files. These are the files generated by the Java compiler, Java C, from the command line or from using any IDE. These class files are then compiled, interpreted by the JVM and converted into executable code within the JVM. Java bytecode runs in a JVM, Java virtual machine. Java virtual machine runs the same way on all the operating system, hence it is machine independent. How to compile and run Java program. Java programs are compiled using Java C command from the terminal on Linux, Unix, or CMD console on Windows, or even terminal on the Mac operating system. Generic command is Java C, filename.java or Java C, static.java that will compile all the files in the current directory. It can compile multiple files. How to set Java C to be available everywhere in the computer? Watch my video on setting Java home in the configuration playlist. To run Java program, we issue the command Java and main method file name. Only the name, no extension. So Java will run the file. This file must have main method. We can also use IDE such as IntelliJ, Eclipse, NetBeans, JCreator Pro, BlueJ, JGrass. Some are very high-end IDEs and some are very lightweight and good for new programmers. Or you can use online compilers like Replit, Codiva, JDoodle, ID1. During the course, I will use NetBeans 13 with JDK 14. You can use any IDE or even a notepad to write Java programs and use core Java from terminal to compile and run the application. So first program, Hello World. It is customary to make a Hello World program when we start learning any programming language. Every Java program must be written in a class. The executable class must contain a main method with the signature public static void main string, and this is array of args. And we will talk about the components and anatomy of first program. The following statement will display hello world to the console screen. System.out.println out is an object to point to the current terminal or console output, console screen. So this will println mean print new line. So hello world will be the parameter to the function that will be printed to the screen. Okay guys, as I said, I am going to use NetBeans IDE 13 and with JDK 14. So I have created a project for Java course and I will create the first program file. Let's name it hello world. Okay, so this is the anatomy of the Java class. This is a command Java document and we will discuss it when we talk about the comments. Normally comments are used to document the code. Public is the access modifier, class is the class. Every Java program must be written within the class. Hello world is the class name, and if the class is public, it must have the same name as the class name. The file name and class name must match. So this is our simple first program. We will add main method public static void main string args. So this is our main method. This is access, public access, accessible everywhere. Static, it is related to the class, and this is the entry point of the program. This is command line arguments array. When we pass commands from the console or other terminals, we will access them through argument. So we will simply print the first line, system.out.println hello world. We can compile and run with this command and hello world will be printed here. This is our first program and this is the beginning of Java programming language. Thank you guys. Please subscribe to the channel and promote the content. See you in the next video. Hello guys, welcome to Java core programming course. Section 1, lecture 2. Today's lecture is about data types and variables and constants. So lecture 2 agenda, data and variables, naming variables, primitive or intrinsic data types, and data type size and ranges. Let's begin our lecture. So data and variables. A variable is a named block of memory we use to store information. Consider memory is a contiguous or continuous blocks of memory. Each block is used to store something, and we can store variables in the we can name the block to store some value. Each block of memory can store a single type of information. This is important, single type of information. We cannot store two types of information within the same block of memory. This means that if you declare an integer variable, it can only store an integer. We cannot store any other type of value within the block of memory. So what happens if we assign something different from integer? So we will discuss that point when we talk about casting. That is why Java is a statically typed programming language. That means Java compiler must know every variable, every type of variable must be declared and associated with some kind of data type. Explicit values in the program are called literal values. For example, when we name a block of memory through a variable name, we put something or place something into that memory block. That value is called a literal value. For example, integer var is the name of the memory block, but 2 is the value. That is a literal value. Each literal also has a type. Every literal has a type. For example, whole numbers usually are integer values. Can be bytes, short, integer or long value also. Similarly, decimal points are floating point numbers. There are 2 data types in Java that represent those floating point numbers. And we used to have strings and we used to have character data type. We used to have Boolean within the Java programming language. Boolean used to store true and false values. In general, we declare a variable as follows: type and variable name. Type is the data type. For example, int, byte, short, char, whatever. User defined or built-in type. And variable name. We can also initialize the value at the time of declaration or assign a value later in the program. So we can do it on the same line or we can do it on 2 lines. We declare first, then we assign, or we declare and assign it. Naming variables. Variable name is called identifier in Java, or you can say variable name. So each variable must follow some rules. The Java programming language has following rules that must apply on variable names or identifiers. Start with the letter. It must start with the letter, or an underscore character, or a dollar sign. Rest of the characters or letters can include letters and digits. Java is a case-sensitive programming language. That means John is not the same as John with the capital J. So it is case sensitive. A variable name must match the case whenever we use it. We cannot use keywords. Keywords are specialized words as a variable name. Keywords are special words reserved for the Java programming language. For example, int, static, class. There are many keywords that Java has reserved their usage, and we cannot use them as identifiers. Rule of thumb. Variable names should be expressive and meaningful. By means of expressive and meaningful, when we read the name of the variable, we should at least know something about the variable, what kind of information is stored there. For example, declaring int var is equal to 0 is far better and meaningful than declaring int I is equal to 0. So int var will indicate this variable will store an integer value. Similarly, we can use str var to store a string. We can use byte var. We can use, for example, float var to indicate what kind of information we are going to store into this variable. So this will be self-descriptive and documented. So primitive versus primitive or intrinsic data types. Primitive or intrinsic data types are the ones Java provided. They are built in within the Java programming language. So each variable is associated with one type of data type. For example, numeric values. There are 4 types of numeric values in Java and 2 types of floating point numbers. Total 6 numeric values, numeric data types. And character, single Unicode character. Java supports Unicode character set that can store up to 4 bytes of 4 bytes of values that can accommodate almost 65,000 plus different characters and to represent different languages around the world. Boolean. Boolean logical values can only store true or false. Each primitive data type has a size associated with it. Size is the capacity of the data type that can hold the maximum and minimum value. Data type must be declared. When we declare a variable, each variable declared must be associated with the data type. For example, int number of cars is equal to 5. So number of cars is a variable name, int is a data type, and 5 is a literal that has been assigned to the variable. 5 is stored within the memory block, and number of cars is the name of that memory block. In this statement, int is a data type, number of cars is a variable name, 5 is a literal value assigned to the number of cars variable within the memory of the program. So Java supports different intrinsic data types, and this table indicates the ranges, the size, and description of the data type. So first, byte. Byte is the smallest unit. 1 byte can store up to -128 to 127, can occupy 8 bits of memory. 1 byte is 8 bits. Short can store 2 bytes, and this is the range of short data type, and it can store up to 16 bits of memory. So integer int can store 4 bytes of memory, and it is in the range of these values: 32 bits up to 10 digits of number, a billion value, single billion. Tens of billion is require 11 digits. So 11 digits is beyond the capacity of integer variable. So up to 2 billion something we can store in the int data type. Long. Long is the biggest numeric whole number or integer data type that occupy 8 bytes, and this is the range of this data type, and it can hold up to 64 bits, that is 19 digits number, that is quintillion. You can store up to a quintillion in the long data type, that is 19 digits almost. So float is 4 bytes, and it has this range: minimum range and maximum value. Single precision number that can have accuracy of 7 decimal points. Float is the smallest floating point representation of numbers. Double represents floating point numbers with the precision of 14 decimal points, and this is its range. It is very big range of numbers, and it occupies 8 bytes. Boolean stores into 1 bit only 2 values, true and false, or you can say 0 and 1. Logical values of true or false using single bit on or off. Character. Chart data type 2 bytes. Unicode character set. It can occupy at most 65,535 different characters. That almost sufficient to represent all the languages. Hello guys, let's practice for lecture 2. We will declare and assign values to different variables and check if our statements are good to go. So let's create a new program. Lecture 2. Okay. Add the main method. Okay, now we will declare variable. So to declare we need data type and variable name. Let's say int var. Okay, this is declaration. Okay, now assign the value. Int var is equal to 5. This is assignment or initialization. We can do this on a single line or single statement, like int var2 is equal to 3. See, this is data type, this is variable name, and this is literals assigned to the variable. So let's print the values. Int var, okay, copy, and int var2. Let's run it. Okay, so we declared a variable of int type, assigned a value, then we declared and initialized another variable and assigned a value, and then we have printed these two variables. Similarly, we can declare and initialize other data types. For example, long. Let's say this is long, so nothing will change. It will store the tree and it is long data type, and we will print it. It will remain the same. Data type change. So when we declare a variable, we also associate it with the data type, but we cannot assign an other value and other data type. For example, we cannot assign like int var2 is equal to 3.5. This is double value. We cannot assign a double value, means the data type cannot change. If we do, it is a compiler error. We cannot assign another data type unless we cast it. Implicitly means automatically or explicitly. So casting will come in the next lectures. We will discuss those concepts, how to cast one value to another value. That is the conversion. So once a variable is declared, it is associated with the data type and it must stay the same data type. We cannot change it. Okay, so now naming variables. It is important how we name the variable. So over requirements are start with the letter, must start with the letter underscore or sign. If we don't, there will be a compiler error. Okay, wrong name. Let's say int 33 var 0. It is compiler error. It is not allowed. We must start with $sign or see the error has gone. Let's print it. So $var2, run the file. See, it is printed 0. Let's say it has a 15. Run, it will run. Okay, now we change it to underscore. Underscore is also allowed as the first character of the variable name. Okay, let's run it. Program executes because it is allowed. Another thing, another point, case sensitive. So this int var cannot be equal to, let's say, int var. So let's try to access it. System.out.println int var. See, compiler error because it cannot identify this name, this identifier. It is not declared anywhere in the Java program. It must match one of the variables declared. So, and let's print with this. Run. Okay, it cannot run. Let's run anyway. See, there are errors. We cannot use a variable that is not already declared within the program. Okay, int var. Now let's talk about size. Every intrinsic type has a wrapper class. We will talk about more in the next lectures for the wrapper classes. When we go for object-oriented programming, or we will discuss built-in Java classes, for example math, for example string, then we will also discuss the wrapper classes. So int has integer wrapper class, long has long wrapper class, float has float wrapper class. Similarly, byte, short, character, etc. have the wrapper classes. So wrapper classes also define constant values that represent the minimum and maximum value of that particular data type. For example, system.out.println max value of int, integer dot max value. So let's print it. Terminate, run it. Sorry, we need to concatenate, run. So this is the maximum value that an integer can store. Let's see the minimum value. Integer dot min value. So this is the minimum value it can store. Okay. Let's see for the long data type. Okay, let's run it. Okay, this value is very big. This is quintillion, 9 quintillion plus value, 18 digits. Similarly, we can print and we can access the minimum and maximum value of the other intrinsic data types. Similarly, let's see Boolean. Okay, Boolean, let's say flag is equal to true, can only hold true and false value. For characters, we can store a single character. For example, let's say char variable is equal to a, and we can also use a Unicode character. Char var 2 is equal to -u 0041. Let's print these values. Value of char var and value of char var 2. Okay, let's print it. Okay, char value is a because we have assigned a. So this is Unicode representation of ASCII A. So it will print a. If we change it, we can increase it, it will print b. See, it is b. So we can assign a character to a char variable as a Unicode character or a ASCII character. There are also escape sequences. For example, new line. Tab character. and let's say R, carriage return, B, beep sound. So we can use these into strings and other values. That's it for today, guys, and let's see for in the next lecture, and practice these concepts so that you will have more command on Java programming language. Please subscribe to the channel to promote. Like and comment. I will reply. Thank you, guys. Have a good day. Hello, guys. Welcome to the Java Core Programming course, Section 1, Lecture 3. In this lecture, we will discuss how to declare, initialize, and use different variables and constants. Okay, Lecture 3 agenda. Declare integer variables, declare decimal variables, declare character and Boolean variables, and declare constants. Okay, declare integer values. Integer, int value is equal to 1. Integer literals are int by default. By default, this value is integer. Byte value is equal to 2. When we assign an integer literal to a byte variable, it must fall within the range of byte data type, that is minus 128 to 127. Short value 23 must be in the range of minus 32,768 to 32,767. This is 2 bytes. And integer and long value can hold up to 64 bits of data. That is pretty big integer, 18 digits. Integer int itself can hold up to 10 digits of a value, and this can hold up to 18 digits value. For any value larger than 10 digits, need to append L in lowercase or L in uppercase to mark it as a long value. Otherwise, there will be a compiler or syntax error. For example, long value, this is a pretty big number. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. 17 digit number. It cannot be an int. So it must be declared as long by appending a L or L in uppercase. Declare decimal values. There are two types of decimal data types in Java, float and double. By default, a decimal literal is a double value. When assigned to a float, you must append an F or capital F to make it a floating point value. For example, if you declare float value 2.5, you must append F or capital F to make it a float value. Otherwise, there will be a syntax error, because by default, this decimal literal is a double value. For double variables, we don't need to append anything, as a decimal literal is a double by default. So we can assign a decimal literal, a floating point literal, to a double value. Next, the character or the Boolean data types. In character variable, we can hold a single character or a Unicode hexadecimal character. Unicode can be represented in a 4 bytes of a data, 2 bytes of a data. Boolean variable can store only one of the two values, true or false. These are Boolean literals. These are character literals. How to declare constants? In Java, constants are fixed values that cannot change over the course of the program. Java constant is declared with the final keyword. Once it is declared, it cannot be changed. So we use uppercase letters to signify constant values. It is a Java naming convention. Normally, for example, final int Phi in yards is equal to 3, should be feet in yards is equal to 3, final double cm in inch 2.54. These are unit conversions, and Java uses a certain naming convention. For example, all the Java classes normally starts with the uppercase letter. Methods and variables normally start with lowercase letter. Then for the next word, its first letter will be capitalized. For all the constant values, the identifier is all uppercase. That is Java naming convention, and normally it is followed by every programmer. That's it, guys, and let's go to practice these concepts in a Java program. Thank you. Hello, guys. In the previous program, I have used different initializations and data types to declare variable. For example, int, boolean flag, char data type with the single character assignment and Unicode character assignment. Okay, let's create a new program for lecture 3. Okay, add main method. Okay, let's declare variables. Int, let's say length is equal to 25. Let's consider inches, and we need to convert this length into centimeters. Okay, let's name it properly in inches. Okay, conversion rate, so we use constant final int double em in inches 2.54. that is standard unit. Centimeter to inches. Okay, now guys, we need new variable to store result. Okay, double, because we are going to operate on those two, integer and double data type, so the result will be the broader data type, that will be double length in cm. So we will multiply cm in inches with the length in inches, and we have the result. Let's print. Length in inches. So length in inches. Let's copy this. Length in cm. Okay, let's run this program. Okay, something is wrong. Okay, this is wrong. We need to change it. Let's say 2 decimal point. Run point. Okay, so 25 in inches will be 63.50 in centimeter. So this is how we declare and use different variables and different data types, and we operate on them using arithmetic operators. In the next video, I will discuss how to use arithmetic operations in Java programming. That is it for now, and let's catch up in the next video. Thank you, guys. Have a good day. Hello, guys. Welcome to Java Core Programming course. I am hopeful that you are doing very good for the previous lectures and practicing Java programming. Section 1, Lecture 4. Today's lecture is about arithmetic operators, integer division, precedence, and programming example. Okay, arithmetic operators. There are 5 arithmetic operators in Java that are addition operator, that is plus, minus, subtract operator, multiplication operator, division operator, and a modulus operator. Plus addition, all these 5 operators are binary operators. They need 2 operands on left and right to operate. So plus operator adds 2 numbers, and it is also overloaded to concatenate strings. We will discuss more on concatenation when I will go for the section on Java string class and wrapper classes. Subtraction, the minus operator or subtract operator subtracts the left hand operand to the from the right hand operand from the left hand operand. Multiplication operator multiply 2 operands. Division operator divides right side to the left side from the right side, and this is integer division. And if the operands are floating point numbers, it will retain the fractional part. Modulus operator, this will return the remainder of division. Division operator returns quotient of division. Okay. Precedence. In Java, operators are left associated other than OOP equal to operator. I will discuss that in the 5th or 6th lecture, I think, when I will discuss assignment operator. So other operators are left associated, binary operators. Unary operators are right associated. Arithmetic operators are binary operators. They need 2 operands to operate or carry out their operation. Precedence implies which operator has priority over the other. If two or, two or more operators appear to have the same precedence. If in a statement 2 operators appear that has the same precedence, then the leftmost will execute first, because these binary operators are left associated. So in all the 5 arithmetic operators, multiplication, division, and modulus have the same precedence. They will operate first. If 2 of them appears in a statement, the leftmost will be operated first. Then come the plus and minus. Plus and minus both have same precedence. Same rules applies. If plus and minus both appear in same statement, the leftmost will operate first. Hello guys, let's start practicing arithmetic operators and integer division. Let's create lecture 4 class, lecture 4, add main method. Let's declare and initialize some variables. Let's say int x is equal to 5, int y is equal to 3, and int z is equal to, let's say, 12. Okay, first addition. Okay, int result is equal to x plus y. Let's print these. System X, Y, and Z. Okay, now let's print the result. X plus Y is equal to result. Okay, now division, subtraction. Result is equal to Z minus X. Z X. Okay, let's do multiplication. The result is equal to X multiplied by Y. Let's print it. X, Y, and result. Let's put the operators here and multiplication. Okay, now division. Result is equal to Z divided by 4. X. Okay, now second example. Z divided by Y. Z, Y, and result. Okay, let's first run these. Let's add modulus. Result is equal to Z percentage X. And second example, result is equal to Z percentage sign modulus sign Y. Z, Y, and result. Okay, we need to put 2 percentage signs to escape them. Okay, let's run it to see the outputs. Then we will discuss how it happens. Okay, these are the results. So over first operation, first we printed X, Y, Z values 5, 3, and 12. X plus 5, X plus Y, that is 5 plus 3, that should be 8. This is 8. Okay, next we subtracted Z, that is 12, and X. So 12 minus 5, 7. This is our result. Okay, next. Subtraction and multiplication. Multiplication, X multiplied by Y, 5 multiplied by 3 is equal to 15. This is 15. Okay, next, division. This is important to understand. Basically, this is integer division. In integer division, the decimal or fractional point discarded. So Z is 12 and X is equal to 5 and it is divided. So we have a quotient of 2 and remainder 2, that is discarded. So we will get only 2, that is the quotient. This is how integer division is carried out. The fractional part discarded when both the operands are numeric values of integers or long numbers. So next, Z is divided by Y. Y is 3 and Z is 12. So our result is 4. So we get a whole number. So nothing is discarded. So no information is lost. It is important whenever you do division in Java, you must understand if both the operands are integer, there will be integer division. And in integer division, if the number does not divide it equally, the fractional part will be lost. Modulo separator. Modulo Separator operates on integers. It takes two operands and perform a division and return the remainder of the division. So z is 12, x is equal to 5, and when we divide it, we get 2 quotient and 2 remainder. So it will return 2. 2 is the remainder of the division. That was last in this division. Okay, next, z is divided by y. Z is 12, y is 3. So 3 equally divides 12 4 times and remainder is 0. So it returns only 0, nothing else, because there is no fractional part. This is how modulus operator operates. Okay, I have discussed all the 5 arithmetic operators. Now, precedence. How precedence works? Let's see, we have a statement x multiplied by y plus z. So x is equal to 5 and y is equal to 3, and x multiplication sign has more precedence. So these two operators operate first and this one operate later. So 5 multiplied by 3 will be 15 and plus 12 should be 27. Let's print the values. X multiplied by z and plus and result. xy and z and result. Let's print it. Okay, so 5 multiplied by 3 operated first, we get 15. Then we added 12 and it becomes 27. So if a operator has more precedence, it will be operated first. Now in case of same precedence, okay, let's the result is equal to x multiplied by y and divided by, let's say, x again. Okay, let me print it. X, y and x. Okay, and let me change the symbols. This is multiplication and this is division. Okay, so x multiplied by y and y, the y divided by x. Both multiplication and division have the same precedence. So which one will be operated first? If we consider division operates first, we will get 0 here. Y is 3 divided by 5, we will get 0 due to integer division, and multiply by x, it should be 0 result. But this is not how Java operates. Java operates in this case like this. If two operators have the same precedence, like multiplication and division, it operates the leftmost, then it operates the next one. So x multiplied by y will operate first and the result will be 15. Then divided by x, that is 5, and 15 divided by 5 should be 3. Let's check it. Okay, see, 5 multiplied by 3 is 15, divided by 5 and result is 3. This is how operator precedence operates in Java statements. Thank you guys. This is the whole lecture, and please subscribe to the channel and promote the content, and see you in the next lecture. Have a good day. Hello guys. Welcome to Java Core Programming course, section 1 and lecture 5. We continue discussing and studying Java basics. This lecture's agenda. Today's agenda is increment and decrement operators, postfix and prefix form, arithmetic operations on short byte data types, integer arithmetic errors. Let's begin today's course. Increment and decrement operators. Increment and decrement operators are unary operators that operate on a single operand. Plus plus is the increment operator, minus minus is the decrement operator. This operator adds 1 to the operand. Decrement operator adds one, subtracts 1 from the operand. Increment operator increases 1. Decrement operator decreases 1. These two operators have higher precedence than the arithmetic operators. Please keep in mind, precedence is important. Whenever there is a unary operator and a binary operator, the unary will be operated first. These operators only work on integer operands. Okay, next, pre and post operators. Both decrement and increment operators have two forms, prefix and postfix. They have their own implications. For example, prefix increment operator. For example, it increase first then assign. For example, int y is equal to 10 and x is equal to plus plus y. So here it will increase y and then assign it to x. So result will be y is equal to 11 and x is equal to 11. In postfix form, it assigns first and then increase. So in the same example, int y is equal to 10 and int x is equal to y plus plus. In this case, this will assign value of 10 to x and then increase y. So the result will be y11 and x is equal to 10. So same happens with the decrement. Decrement operator in the prefix form decrease 1 first then assign. In postfix form decrease later and first assign. So int y is equal to 10 and x is equal to minus minus y, both becomes 9 9. In case of postfix form, y is equal to 10 and x is equal to y minus minus. The y will be decreased after assigning y to the x. So it will become 10 and y will become 9. Okay, both arithmetic operations on shorter integer types. So this is very carefully, please consider these operations carefully, because whenever we use bytes and short data types and we do arithmetic operations on them, they always converted to integers. And if we try to assign them back to byte and short, there will be a need for explicit casting. If we don't do that, there will be an error. So as we studied, byte and short can store only smaller integer values. But for arithmetic operators, the default integer operation requires integers or long operands. They must be long or int to store the values. When we operate arithmetic operations on byte or short data type variables, they are implicitly converted to int or long variables based on the operands involved, or reference to store the result. So for example, if we have byte b is equal to 5 and we have byte c is equal to 5, and if we do the operation byte result is equal to b plus c, this will be a compiler error and syntax error, because b plus c, the plus operator convert them into integers and the result will be an integer that cannot be stored on the byte, no matter it falls within the valid range of byte. but we have to convert them. If we like to store the result into a byte variable, we have to cast it explicitly using the cast operator. That will be that I will discuss in the lecture 6. Arithmetic errors. How the arithmetic errors happen. For example, division by 0 is an exceptional case of math error because division by 0 is not defined in mathematics. Any number divided by 0 is undefined in math. In programming, it raises an exception and crashes the program. We will read more about exceptions when we handle them in future lectures. Overflow error. There is an other error, overflow. Overflow error is while doing the arithmetic operations on integer data types, the result is a larger value than the maximum limit of integer data type. In previous lecture, we have seen that every integer data type has a maximum limit. For example, byte has 127 maximum number to store and the minimum number is minus 128. Similarly, short, int and long, they have minimum and maximum value. What happens if an operation ends up a larger or the smallest value than their maximum number or minimum number? So this is when an overflow occurs. An overflow normally results in a negative value. For example, if there is a very huge positive number as a result of an arithmetic operation and we try to store it on integer or long, and the result will be a negative value because of the overflow, and that will be a logical error. Underflow error. Underflow is similar to the overflow error. Underflow happens when we get a smallest value that the data type cannot store. It results in an invalid value. So these are arithmetic errors that may happen in the arithmetic operations. All integer data types have fixed lowest and highest values represented by min value and max value constants in their wrapper classes. We will discuss the wrapper classes in future section when we discuss the string class. Along with string class, I will discuss the wrapper classes of the intrinsic or internal data types provided by the Java programming language. Thank you guys. That is all about today's lecture. Let's go to practice these concepts that we have studied today. Hello guys. Let's begin the practice for the lecture 5. Create new class. Name it lecture 5. Add main method. Okay, let's declare some variables. Int, let's say x is equal to 10. Int y. So we initialize it to 0. Okay, let's print them. Printf %d x is equal to and y is equal to a new line x y. Okay, now increment operator. In case of increment operator, we have two forms. Let's try first one. Y is equal to x plus plus. This is postfix form. Assign first, then increase. Let's see what happens to the values. Okay. Let's run it. Okay, see here. X is equal to 10. It is assigned first, then it is increased to 11 because of postfix form. Now let's retain our values back, 10 and y is equal to 0. Okay, prefix form. In prefix form, y is equal to plus plus x. In this case, both of them will have same value because it increase the value of x and then assign it. So let's print and check. See, we have x is equal to 11 and we have y is equal to 11. Same goes for the decrement operator. Okay, same values, and we do postfix decrement x minus minus. Then we will reassign them. Let's print it here, postfix, and this is prefix. In case of prefix, values will be different because it decrease first and then assign the value. Run. Okay, here decrement operator, we have x10 y0, so we used postfix form. It assigned the value first, then decreased x, so y is 10 and x is 9. Here we have used prefix form. In case of prefix form, it decreased the value of x to 9 and then assign it, so both values will be same. Okay, now next, our next topic is shorter data types. Okay, let's see. Shorter data type, let's say integer and arithmetic operations. Okay, cool. Let's we have byte b is equal to 5 and byte c is equal to, let's say, 10. Okay, that is good so far because these numeric values are literals fall within the range of byte. Now another variable. So if we add 10 plus 5, it becomes 15. So if we declare byte a is equal to 15, that is absolutely fine. There is nothing wrong. Now if we operate, let's say plus, so byte result is equal to b plus c. Here error, because when we used plus operator, these two byte values converted into an integer, and the result of this operation is an integer. We cannot directly assign an integer value to a byte. We have to convert it by using cast operation. In lecture 6, I will discuss the usage of cast operation. So it has to be integer or it has to be cast to byte. See, now it is int and it is all right. So let's print result. It should print 15. Okay, it has printed 15. Same goes for the short value. Let's say short, we have s is equal to 9 and s is equal to s plus, let's say a, let's say b. Okay, b is 5. So result should be 14, but it is an error because of arithmetic operation. Same goes for division, multiplication and subtraction operators and modulo operators. All these 5 arithmetic operators convert the shorter data types into an int or long based on the operand types. So we have to use result here because the result is an integer variable. Okay, let's print it again. We have 14 here and we have 14 here. Now in case of, let's say we are combining two different results. Let's say int I is equal to 3 and result is equal to 3 plus a. No error because this is a is byte. Okay, byte will be promoted to integer. Integer plus integer, result is integer, and we are perfectly fine with the result. Okay, that is the result of addition of C and A. Okay, now arithmetic errors. In case of arithmetic errors, the overflow and underflow occurs. Okay, let's try this. System.out.println. Okay, integer dot max value plus integer dot max value. These are two largest integer values. Let's see what happens. Okay, see the result is -2. This happens because of this is the largest number, the maximum number an integer can hold. So the result will be, let's store it to some variable. Let's say result is equal to this. Okay, and print this value. -2. This is how overflow happens. Overflow happens when the largest value that is bigger than the maximum number our data type can hold, and the larger number is truncated, and the result is converted to negative because of binary representation, because all these integer numbers are stored in the memory as a binary numbers. Okay, now underflow. Okay, let's add the minimum values. Main value. Okay, and this is also main value. Let's see what happens to the result now. Run it and see, it is 0. These are the minimum values and the result is 0. And if we don't use and print the minimum value, and this is how smallest value is represented. This is the smallest value that an integer can hold, represented as -2 power 31. This is the value, and if we add them, min value, the result is 0 because the value is truncated. It is a junk value, basically a logically incorrect value. So what happens in case of math error? Math error occurs when we divide by 0. Let's say int x is equal to 9 and int, let's say y is equal to 0. I think we have these numbers already. Let's set the values. Okay, divide system print x divided by y. This is division by 0 exception, mathematical error. See, arithmetic exception, because division by 0 is not allowed, and it is not even defined within mathematics. So whenever we do division, we must consider the denominator should not be a 0. So these are the arithmetic errors and post and prefix of increment and decrement operators and arithmetic operations on shorter data types and what happens. We have practiced all the concepts and I hope you have learned it. Good. Thank you guys. Have a good day and see you in the next video. Hello guys. Welcome to Java Core Programming course. This is lecture 6 of section 1 and this will be the last lecture for this section. In the next video, I will start section 2 based on branching, conditional statements and loops. Let's begin today's lecture. So today's agenda is casting, explicit and implicit casting, assignment operator, OOP assignment operator, bitwise operators and shift operators. Let's begin. Casting. Typecasting is when we assign or convert one data type to another. Java supports two types of casting: implicit, that happens automatically, and explicit, that we have to do it. Otherwise, there will be a compiler error. Implicit casting occurs between shorter or narrower data type to larger or broader data type. For example, int to n, int to long, float to double. On the other hand, explicit casting occurs when we cast broader data type or larger data type to shorter or narrower data type. For example, long to int, double to float, int to byte. We have to cast it explicitly through programming. It does not happen automatically. If we do not cast it, it will end up in compile error and program does not compile. In explicit data type casting, we have to use the cast operator, that is parenthesis and data type. For example, byte b is equal to 5 and int I is equal to 3. And if we assign I, that is an integer, to the byte, we have to cast it to the byte data type. And to cast, we need parenthesis and data type name. Okay, another thing, at the time of casting, in the previous lecture, I have discussed overflow and underflow errors. If there is a bigger data type, data value that cannot be stored in a byte or a short or an integer, casting it will lose the precision or the value. Maybe it will result in a junk value. So make sure when you cast some value or some larger data type value to a shorter data type, you must consider its size, how many bits it can store. Okay, assignment operator. Java uses equal to sign for the assignment of a value to a variable or a constant. So whatever comes to the left side of assignment operator is L value, and whatever comes on the right side of the assignment operator is R value. R value is always assigned to the L value. Variables can be assigned values anytime during the lifetime of the program. That is why we call them variables, because their values can change during the runtime of the application. Constants can only be initialized once and don't change throughout the program. Constants can be initialized inside a method and inside a loop scope or through inside a constructor, class constructor. We will discuss this when we start object-oriented programming. So Java also provides OOP assignment signs where OOP can be bitwise operators, arithmetic operators, or shift operators. For example, plus equal to, that is, add two values and assign it to the left side operand. Divide equal to, and equal to, that is bitwise operator, bitwise AND operator, and right shift equal to, that will right shift the operand and assign it. There is only one assignment operator if it comes alone, this one. There are total 11 OOP equal to or OOP assignment operators. 5 combined with arithmetic operators. There are 5 arithmetic operators and we can combine them with the assignment operator. There are 3 bitwise operators and, or, and, ZOR. We can combine them with the assignment operator. The fourth bitwise operator, that is tilde, the complement operator, cannot be used here because complement operator is unary operator that operate on single operand. And 3 combined with shift operators. There are 3 shift operators: left shift, right shift, and unsigned right shift. These 3 operators can also be combined with assignment operator. So there will be total 11 OOP assignment operators in Java. These are shift operators: right shift, left shift, and unsigned right shift. Okay, now bitwise operators. All integer variables are internally stored as a binary base 2 numbers that are consist of zeros and ones. Java provides 4 bitwise operators that operate on binary bits. These operators are AND, OR, ZOR, that is represented by the caret sign, and tilde, the complement operator. Truth tables. AND operator is a binary operator, only true if both operands are true. In case of bits, result is 1 only if both side bits are 1. This is the truth table for the AND operator. For example, if we have operand A and operand B and their values false, false, result in false. Sorry, this should be A and B. False, true, result in false. True, false, result in false. True, true, result in true. That is the only combination of A and B that will result in B and B, A and B is equal to true. Okay, now OR operation. OR operation is represented by the pipe sign, single pipe sign. So it is also binary operator. Any operand true, the result is true. Or if it is operating on bits, any bit is 1, the result is 1. So here A, B, A or B. So false, false, false. That is the only combination when A and A or B will be false. All the other combination, false, true, true, false, true, true, all result in true values. Okay, now ZAR operator. ZAR operator is represented with the caret sign. This is typo. Consider it ZAR operator. That is represented by the caret sign. So binary operator, both sides are different, it is true. Otherwise false. In case of bits, if both bits are 1 or 0, result is 0. Otherwise 1. So false, false. If A is false, B is false, result is false. A false, B true, result is true. A true, B false, result is true. A true, B true, result is false. So when both bits are same, are the true or both values are true or both values are false, result will be false. That is the ZOR operation. Now the bitwise operator continued, and we are discussing complement operation. Complement operator is represented by tilde. Tilde is a special character that is that operates on single operand, and it converts 0 to 1 or 1 to 0. It, in other words, we can say it inverses the value. So false becomes true, true becomes false. 0 becomes 1, 1 becomes 0. And it's truth table. A, and because it operates on single operand, so we have only one operand here. So true becomes false and false becomes true. Now the shift operators. Left shift operator. This shift the significant digits towards the left and fill the number with 0 bits. Right shift. This shift the significant digits towards right and fill the number with the signed bit. So this is a signed right shift. This is unsigned right shift. It shifts the number towards right and fill the number or pad the number with zeros. There is a significant difference between these two operators. This will not change the sign. Negative number remains negative, positive number remains positive. This will change the sign. Positive will remain positive and negative will become positive. Okay. These operators are used in the form operand, operator, and number. Operand is the variable that we are going to operate. Operator is the operator, one of these three operators, and the number of bits we are going to shift. For example, some variable and left shift operator 2, it will left shift the variable 2 positions towards left and pad the number with 2 zeros from the right side. Hello guys, let's let's practice lecture 6 concepts. Create new file, lecture 6. Add new method, main method, public static void main and string parameter. Okay, let's create few variables. Okay, byte, let's say b is equal to 3, short s is equal to 9, int I is equal to, let's say 4. Okay, the first concept, casting. Okay, implicit casting. Let's print the values. B is equal to S is equal to and I is equal to BSI. Okay, we can reuse this statement to print the other. Something is wrong. Okay, we need F, permitted output. Okay, so implicit, we can automatically cast shorter or smaller data type to the larger one. So I is equal to 3. Sorry, I is equal to B. Okay. I is equal to S. This is also okay. Let's print the value side by side. And print here again. Okay. Let's run it. Okay, see, we have B is equal to 3, S is equal to 9, and I is equal to 4. And then we assigned B byte to the I, and it becomes I is equal to 3. Then we assigned S to I, and it becomes 9. So we do not need any special casting to cast a shorter or smaller data type to a larger one. But in case of explicit casting, Okay, I is equal to, let restore the original value. Okay, b is equal to I, error. S is equal to I, error, because we cannot cast larger data type to a smaller data type automatically. We have to cast it. So to cast it, we need cast operator, and parenthesis is the cast operator, and inside it we write the data type name and short. Okay, now we can no error after casting, no error after casting. Okay, let's print the values and let's run it. Okay, so we have the updated values now. So guys, keep in mind, shorted data type can be implicitly or automatically casted to the larger data type, but larger data type must be explicitly casted to the shorter data type. And keep in mind, if there is a larger value, the result will be a illogical value. Let's test. Overflow. Okay, let's say I is equal to max value. Okay, we cast it to short. Okay, print. Let's print here so that we know the maximum value of I is there. Run it. Okay, okay, so I, we store the maximum value of integer into I, that is 2 billion something. That is, max value is equal to 2 power 31 minus 1. That is the maximum value of an integer. So we casted it. Casting operation is okay. Casting is okay and legal. But question is, overflow will result in invalid value. So our answer will be wrong. And due to overflow, it becomes -1, negative value. So whenever you perform a conversion through casting from larger data type to the shorter data type, you must consider the maximum value of the target data type so that your results will not affect. Okay, now next concept, assignment operators. We already used it lot of times. We assign right hand value to the left hand value. Okay, let's see OOP equal to operators. There are, as I mentioned in the video, 11 OOP equal to operators. So we can combine, let's say I plus is equal to B. Legal conversion as arithmetic operation make byte to integer while arithmetic operations. So it will run. Okay, it works fine. And this value becomes overflow. So let me change the value of I. I is equal to 4. So that we can see the accurate result. Because we stored maximum value, added byte, the byte value is 3, so it result in overflow. Run. So now we have I is equal to 8. 4. How it becomes 8. B is equal to 4. B is equal to 3 and 4. Okay, B's value is 4. Somewhere we have altered the values, so it becomes B is equal to 4 and we stored 4 here. So 4 plus 4 is equal to 8. S is still, let's change S. S is equal to 3, let's say. Okay, so we have a valid value in the chart variable. Similarly, we can use other variables. Okay, let's try bitwise operators. Okay, so we have I is equal to, let's reset them. B is equal to 2, I is equal to 5, and S is already equal to 3. Okay, now let's print values as binary. Okay, system dot out dot print percentage %s percentage %d in binary. Okay, percentage %n. Okay, B is equal to byte dot to let's over integer to binary string. Okay, we can promote it. Let's say it becomes, we take two integer values, int x is equal to 5, int y is equal to, let's say, 7. Okay, so x and x. Second value y, and this is also y. So let's print it. Run file. Okay, so 5 in binary and 7 in binary. The integer is 32-bit data type, and the leading zeros are not displayed. Okay, so consider there are these numbers are 3 1 0 0 1 2. Okay, 3, and there will be 29 more zeros on the left hand side. Okay, let's operate. Int result is equal to 5, let's say, and y. Let's see what is the result of this value. Result and result. Okay, so 7, these are two binary numbers, 5 and 7, and these two bits are 1. So AND operator, truth table, 2 bits are 1, result is 1. 2 bits are 1 and result is 1. In the center there is 1 bit is 0, another bit is 1, so result is 0. So it becomes 101. 101 is equal to 5. Okay, now OR operation. OR operation, any bit is 1, result is 1. So we will get 7, because 7, all 3 bits are 1. So 2 bits are 1, result 1. 1 bit is 1, result 1. And again 2 bits are 1, result is 1. Let's make some bigger number so we will have a different results. Let's say 11. Okay, run. Okay, here, see, we have 101 and 1011. So when we did the OR operation, we get 4 ones. And when we did the AND operation, only first bits are same. So first bit is only 1. Now the XOR operation. In the XOR operation, when there are two same bits, they become 0, and alternate bits becomes true. So caret sign, and let's see the result. Okay, this is the result of XOR operation. In the XOR operation, first bits in both the operands are 1, so that become 0. Other three bits are different, 1 0, 0 1 and 1 0. They are true. So this is the answer for the XOR operation. Now the complement operator. Okay, complement operator operates on single operand. So we will use, let's say, y. Sorry, tilde. Okay, tilde operator. Tilde operator converts the bits from 0 to 1. So we have y. Y value is 11. This is y. So see, first 4 bits, 1 converted to 0. This one is also converted to 0. This 0 converted to 1. And this 1 is converted to 0. These are first 4 bits. Rest of all the bits up to 32 bits are 0 in this number. So they are converted to 1s. And this is signed bit. Signed bit is for the negative number. So it becomes minus 12. Okay, now shift operators. Okay, let's set our values again. X is equal to 5 and y is equal to, let's say, 17. Okay, now left shift. Okay, we use binary numbers. Okay, this will be x and y and y. Let's print them to see their binary pattern. Okay, these are our binary pattern. 5 in binary number and 17 in binary number. Now we will do the left shift. So y is equal to y left shift 2. Left shift y 2 bits. Okay, let's see what is the answer. Let's make it result. So we keep the same numbers. Result. Okay. Run. Okay. See guys, this is the number 17. And we left shift 2 bits. So 2 zeros are padded. After padding 2 zeros, it becomes 68. Because these are the significant numbers, when we shift towards left, they multiply or they add up. Now right shift. We right shift 17 2 bits. Okay, after right shift, run the file. Okay, see, after right shift, we shifted, this is the number, we shifted these two discarded and we left with 100 and 002 bits are padded from here. So no sign changed because this is a positive number, and in signed right shift the sign bit remain same, only zeros are padded. So we left with these three numbers 001, they become 4 because these are binary numbers. So basically right shift sign shift is a division. Now unsigned the in the unsigned right shift. Okay, let me run it, then we will discuss. Okay, see, the result is same result, no change here. Why no change? If both these numbers, both these operators, signed right shift, unsigned right shift, produce same result, why do we have these two operators? That is the big question. So how they work, you need to understand. This is signed right shift. This will pad the zero. Sorry, this will pad the signed bit from right side. So from left side. So positive number, sign bit is 0 and it will keep on padding sign bit from the left side. If the number is negative, the sign bit is 1. So it will keep on padding 1 from the left side. In case of unsigned right shift, for the positive numbers, this operator will pad 0 from left side. In case of negative number, this operator again pad the 0 bit. If it pads 0 bit into a negative number, that number will become positive number and will be a very big number. Let me show you an example. Okay, we have minus 17. Okay, we have a negative number and we run it now. Okay, see here what happens. Negative numbers, ignore these because these two are the operator on signed numbers. Okay, so minus 17 shifted 2 points towards left and 2 zeros are padded and number decreased. Minus 17 becomes, number increased, become minus 12. In case of signed right shift, here we have 17, this number, y is 17. Okay, we printed y here and let me write it here so clarify. Run the file. Okay, so we have this y 17 in binary. This is the negative number. So we right shift 2 decimal points. So sign bit added. Sign bit added. These 2 bits are discarded. This is here. So these 2 bits are discarded and we left with these 4 last bits and rest of the number is same and its padding is signed bit. The for negative number signed bit is 1, so it becomes minus 5. In case of unsigned right shift, okay, we discarded these 2 numbers and last 4 numbers remains here, these 4 bit patterns, and we padded it with zeros. So number changed into positive number and this is a very big number. 1 2 3 and 4 5 6 7 8 9 and 10, 1 billion something. So minus 17 unsigned shifted right toward 2 bits becomes 1 billion plus number because of padding of 0 instead of signed bit. That is all guys for the bitwise operators and shift operators. I hope you have learned a lot, and if you have some questions on this section, please comment under the videos. I will reply. And in the next section, I will start branch statements, if else, switch statement, and for loop, while and do while loop, and assertions and other control statements. Thank you guys. Please subscribe to the channel and enjoy. Have a good day. Thank you.